Okay, we're going to look at composing functions to determine whether or not they're inverses of each other. So let's go ahead and start off with a function. Here we have a quadratic function, and we want to find the inverse. So first of all, we need to restrict the domain. So remember, in order to find the inverse function, the original function has to be a one-to-one. And if we were to graph this, we would know that this is not a one-to-one function. So we would have to restrict this graph to x is greater than or equal to 0. Okay, so let's go ahead and start finding the inverse. So switch in the x and the y. Solving for y. So our inverse function, I'm going to use function notation because that's what I started off with. Okay, so how to verify that these are inverses of each other using a composition. So remember, a composition looks a little something like this. Compose, F, compose, and we're going to plug in the inverse into the original. Now if we plug in the inverse into the original and we simplify it, x should be the result if they are inverses of each other. So let's take this original function. We're going to plug this function in here. Okay, so we're going to have the square root of x minus 1, plugging that in for x, plus 1. Okay, remember, if these are inverses of each other, when we compose them, we should have a result of x. So the square cancels out the square root. And combining our like terms, the -1 and the 1 cancel out. And that's how you can prove that two functions are inverses. You can plug one function into the other function and then simplify it, and if the result is x, then they're inverses of each other. And vice versa. If you plug the original function in here, in for x, and your result is x, they're inverses of each other. Okay, let's take a look at another example. Here we have a function 3 times the cube root of x plus 1. Okay, we know this is a one-to-one function because if you graph a cube root function, the graph looks a little something like that. And it passes the horizontal line test, so it is a one-to-one function. So now we're going to find the inverse. Solving for y, divide by 3 on both sides. Whoops. Okay, undoing the cube root, we're going to take the third power on both sides. So here we get x cubed over 3 cubed, which is 27. Subtract 1 on both sides. So we're going to have x cubed over 27, subtract 1, and that's going to be our inverse function. Notice the inverse of a cube root is a cubic function. Now let's go ahead and use composition to prove that we did this correctly, that they are indeed inverses of each other. So I'm going to go ahead and take this function right here, and I'm going to take it and I'm going to plug it into the original in for x. Now remember, the result needs to be x if they are inverses of each other. So there is my x right here. I plug this function in, it's a composition. Okay? So simplifying this, we know that a negative 1 and a positive 1 is 0. And the cube root of x cubed, that would be x to the 3 over 3, which would be just x, because 3 divided by 3 is 1. And then the cube root of 27 is 3. And then the 3's cancel, so we get x. So there you go. Composing functions to determine whether or not they're inverses of each other. All right, I'll see you in class.